Hello viewers, welcome to this video. This video is about provisioning your Kubernetes cluster in AWS using their managed Kubernetes service EKS, Elastic Kubernetes Service. And this time we will be using Terraform to provision our EKS Kubernetes cluster. Okay, so I haven't done any videos on Terraform, but I'm planning to do a series on Terraform, which I'll be starting soon. But for this video, I'm assuming that you've got some Terraform knowledge. You've used Terraform to provision your infrastructure and so on. Okay, so a while ago, I did a video on how to create your Kubernetes cluster in AWS using EKS, using the command line eksctl. So if I search in YouTube for eksctl, or if I choose just me eksctl, and there you go. So that's the video that I did a month ago about creating Kubernetes cluster in AWS using eksctl. So we will have a similar EKS Kubernetes cluster this time, but we will be provisioning using Terraform, which will be quite simple. We've used eksctl. That's also an automated way, or you can use Amazon's management console. If you're learning for the first time, you can see what's involved. There's a documentation in AWS about how to getting started with eksctl, with your EKS. That tells you step-by-step process how you can create your EKS cluster. So you'll get a good understanding of what's involved, what resources you need to deploy in your AWS cloud to get your EKS cluster up and running. But we've done a video on eksctl command line way, so now this time we will be using Terraform. So I've got Terraform version 0.12, and we will be using a guide here from HashiCorp Terraform EKS intro. I'll put a link to this description in this video description. So AWS EKS introduction. So basically we'll be going through this documentation to set up our cluster using Terraform. So you can go through this documentation and see what's happening and what resources it will deploy and so on. But I've got everything covered, and I've got my notes here. So what we are about to provision using Terraform is just this. So we will download a Terraform repository from HashiCorp. So they've got all the Terraform files ready. We just need to download that GitHub repository, do a Terraform init, Terraform plan, Terraform apply, and we will have our cluster ready in about 15 minutes. So when I did the Terraform apply, it took me 15 minutes for the EKS cluster to be deployed, and then node group to be deployed. And then when it comes to deleting or destroying your infrastructure using Terraform Destroy, it took about another 15 minutes to destroy, but that's all it takes. So when it comes to the resources that we are deploying using Terraform, basically we are creating a VPC cluster, a VPC, and we will have two public subnets. We will create a route table and route table association. So once we create the route table, we associate that route table to these two public subnets. We create an internet gateway, attach it to the VPC. We then create an EKS cluster where we have our master nodes that are managed by AWS. And we will have our node group. That's where we have all the worker nodes. And for this demo, we will have just one worker node. And then we will have a security group and an ingress rule attached to that security group. And we also need a couple of IAM roles. So one IAM role for the cluster, EKS cluster, and another IAM role for the nodes in the node group. And we'll be attaching two policies to this IAM role and three policies to this IAM role. Okay. So these are the resources that will be deployed when we use Terraform. So if I take a count here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. So we will be deploying 18 resources. Okay, so now let's download the Terraform repository. HashiCorp or GitHub Terraform provider AWS. I'll also put a link to this one in the video description. So basically that's the one that we need to be cloning. So clone that, going to cd to my play directory, git clone, paste that. Okay, so it's downloading now. At the moment we are cloning our repository, and once that's done, you need to have your Terraform installed. The other requirement is you need to have your AWS CLI configured. So Terraform needs to know how to interact with your AWS cloud. So I've done a video on how to configure your AWS CLI. So you need to have your AWS CLI configured, and then you should be ready to use your Terraform. Okay, so let's go into the Terraform. So what I'm going to do now is, instead of using the master branch, because it keeps changing, I'm going to use a tag version 2.51.0, so that when you are trying this out, and please try version 2.51.0, if you try it on the master branch, things might change depending on when you're watching this video. So I'm using this tag version 2.51.0. So I'm going to switch to that tag, git checkout version 2.51.0. Okay, so if I open up my Visual Studio Code editor, so that's the editor that I'm using. Okay, so that's Visual Studio Code editor, and okay, let me close that. So in here I'm going to go to the examples directory, and that is this EKS getting started directory. Let's cd to that EKS getting started, and let's open up the Visual Studio Code editor now. Okay, EKS getting started. We've got all our Terraform files here. Excuse me. Okay, so back in the terminal, let's do a Terraform init. So that's the first command we will be doing, Terraform init. That's going to download all the providers that are being used in this Terraform init. And you can see here we are using a few providers. So one is we're downloading the plugin for the AWS provider, and another plugin for the HTTP provider. So that's done. And now let's do a Terraform plan. So Terraform plan, it's not going to apply anything, it's just going to show you what it is going to do. Okay, so Terraform plan, it's going to list you the list of resources that we are about to deploy in our AWS cloud. Okay, and so these are the list of things, and you can see here 18 resources to add. So that's what we saw in our notes here. So these are the list of resources. So if I show you the Terraform plan output, you will see a resource for each of these things that we discussed. Okay, let's start from the beginning. Okay, so that's where it starts. So AWS EKS cluster, which is that one here, and we've got a node group, which is that one, and we've got an IAM role for the cluster, which is this one, IAM role, and we have an IAM role for the node group, which is this IAM role, and then we have two policies. So the policies are Amazon EKS cluster policy, Amazon EKS service policy, and they are being attached to the role Terraform EKS demo cluster. So if I scroll above, the IAM role that we created for the cluster, this IAM role has the name Terraform EKS demo cluster, and if you look at these two policies here, we are attaching those policies to that particular role. And again, we've got additional 3 roles, Amazon EC2 container registry read-only role. These are all Amazon managed policies, and Amazon EKS worker node policy, and then we have a CNI policy, and all these 3 policies are being attached to the Terraform EKS demo node role, which is this one, which is this role here. Okay, so those are the roles and policies. And then we have our internet gateway is attached to the VPC. So we have the VPC ID here. So that's internet gateway. We have a route table, which is here, route table. And then we have a couple of route table associations, and you can see here to which subnet we are associating this route table, because we've got 2 subnets, 2 public subnets. We are creating 2 route table associations, and then we are creating a security group. So that's the security group here. and we are attaching a security group rule, which is an ingress rule. This rule is about giving you access, giving your workstation. So now I've got my Linux workstation here, and it's giving the workstation access to the EKS cluster. So that's the security group we are configuring, and you can see here it has configured my current external public IP address. So that's done by this Terraform here. So we are using the HTTP provider to grab my public IP address. So we are using this URL to grab my public IP address. If I copy that and do a curl on that one, so it gives me my public IP address. All right. So basically we are using this HTTP provider. We are querying an URL to get my public IP address, and then adding that public IP address to the ingress rule for the security group. Okay, so we've got our security groups, and we've got two subnets. These are all public subnets. So we've got these two public subnets, and finally the VPC. So the VPC CIDR is here. So that's the VPC here. Okay, so now we are ready to apply this Terraform files. Terraform apply will provision all these resources, all these 18 resources now. But I want to do a simple change to this. So if you want to change the name of your cluster, if I go to the very beginning, EKS cluster, it gets the name Terraform EKS demo, and I will show you where each resources are in the Terraform repository. So this one is deploying the AWS EKS cluster resource, and the name is Terraform EKS demo. And if you go here, it's this Terraform file, EKS cluster. And if you go to the bottom, so that's the resource that's responsible for this one here. So where it gets its name is var.clustername. Var is the variable which is defined in the variables.tf file, cluster name. So the cluster name is Terraform EKS demo. If you want to change it, you can change it here. And then we've got the node group, which is defined in this Terraform file. If you scroll to the bottom, that's the resource. Cluster name is AWS EKS cluster.demo.name, which is defined here. AWS EKS cluster.demo.name. It gets the name from the variables, so it gets passed on to all the other Terraform files. And we have this IAM role for the cluster, which is defined in the cluster. So that's the IAM role. And then we've got the IAM role for the node, which is defined in the worker node. It's this role here. And we have two IAM policies attached to the cluster role, which is defined in here. The two IAM roles, the two IAM policies. And then we have three IAM policies attached to the role in the worker node. So that's defined in this file. So we've got these three policies. And we've got the internet gateway, which is defined in the vpc.tf. We should be having an internet gateway. There it is, internet gateway. We've got the root table and root table associations. That's again defined in the VPC. So we've got the root table and the root table association. So we've got just one resource for the root table association, but you can see the count as 2. So because we've got two public subnets, there's two root table associations. And then we've got the security group and then the security group rule, which is defined. It's not defined in here. So security group, let's look at EKS cluster. Yes, we've got the security group and we've got the security group rule. And if you look the CIDR block, which is this one, CIDR block, so it's grabbing that from local.workstation external CIDR, which comes from this Terraform, locals.workstation external CIDR. Okay, and we've got two public subnets, which is defined in the VPC. Subnets, yes. So we've got the subnet and count is 2. And finally, we've got the VPC section, which is defined here. VPC demo. Okay, cool. So we've got all the resources. If you want to change anything, if you want to change the CIDR for the network CIDR for your VPC, you can change it here and so on. And if you look at the subnet, at the moment it's being created in US West 2A and US West 2B. I want my VPC and subnets to be created in the EU West 1 Ireland region. So the place to change is providers.tf, and we are specifying the AWS provider. We want to deploy our resources in AWS. So we are choosing the AWS provider, and the region is US West 2. I'm going to change that to EU West 1. Save the file, and if I do Terraform plan again, so now we should be seeing our subnets and VPCs getting created in the EU West 1 Ireland region. Okay, so now if I look at the subnets, EU West 1B, EU West 1A, so that looks fine to me. So now we are ready to apply our Terraform configuration. Okay, so now we are ready to do a Terraform apply, and if you do Terraform apply, it's gonna ask you for the confirmation, but if you want to skip the confirmation, you can use Terraform apply -- auto approve. But I would always like to do a Terraform apply without confirmation, with confirmation, to see what it's actually doing. This is the final chance to review what it's going to do, and let's once again confirm that it's going to do the right thing. Yes, it's adding 18 resources, and we've gone through all these. EU West 1A, EU West 1B, all looking good. And now just type in yes. That's it. So now you have to just sit back and relax and see. It's going to create all these things, all the 18 resources for you. And at the moment it's creating the security group rule is created, and then it will create the EKS cluster, which is the time consuming bit. So now it has gone to creating the EKS cluster, which takes about 12 to 13 minutes when I tested previously, and then it will create the node group, which takes another 5 minutes or so. So in about 15 minutes we will have our EKS cluster ready. Then we can log into our AWS management console and review what it has deployed for us, and I will also show you how to interact with your cluster, how to download the kubeconfig file, and how to connect to your cluster and so on. Alright, I'm going to pause the video here and come back after 15 minutes. Alright, so the Terraform apply command has completed, and if I scroll above, it took, for the Kubernetes cluster to be created, it took less than nearly 10 minutes, and for the node group it took about 2.5 minutes. So in total it took about around 13 minutes for the cluster to be set up. So now how do we access this cluster? And you can look at the resources that it has deployed using the Terraform state command. So Terraform state, so you will have the state file, where is it? Terraform state, terraform.tf state. So that's the file that it has created. That's the file where it stores information about the resources that it has deployed, and you can use the command terraform state list, and it will show you the list of resources that it has deployed: VPC, subnet, security group, route table, internet gateway, role, policies, cluster, node group, and so on. So it also has an output file, outputs.tf, where it defines some of them, and one of the output that is configured is kubeconfig, and the value of kubeconfig is local.kubeconfig, which is this one, config, defined under the locals section. So now we can do terraform output kubeconfig, and that's the kubeconfig file that we will be using to interact with our cluster. So it has the certificate, and that's the name of the address, the URL of the Kubernetes API server. Alright, so terraform output kubeconfig, and I'm going to redirect that to .kube/config under my home directory. So that's the default location for the kubeconfig file. So we've got our kubeconfig file, so now we should be ready to interact with our Kubernetes cluster. But there is one other thing that we need to do before we can successfully interact with our Kubernetes cluster, which I'm going to show you now. And if I do kubectl now, kubectl get nodes or kubectl cluster info. So So that's the error that you will get. Basically, you need to download the AWS IAM Authenticator before you can interact with your cluster. So let's download that. So going to the browser, AWS IAM Authenticator download. Installing AWS IAM Authenticator. Go there and choose Linux depending on your OS, whether it's Mac OS, Linux or Windows. So I'm using Linux, so I'm going to copy this command. Copy that command and I'm going to paste that. So it's downloading AWS IAM Authenticator binary, and then we need to set executable permission for that binary and then move that binary to under user local bin, and then we should be able to interact with our cluster. So change mode +X AWS IAM Authenticator, and I'm going to move AWS IAM Authenticator to user local bin. And now if I do AWS IAM Authenticator version, so version 0.4.0, and now if I do kubectl cluster info, cool, so that's our cluster. So Kubernetes master is running at this URL, kubectl get nodes. So we have just one node and it's in the ready status. So we won't be able to see the master node here because master nodes are managed by AWS, because this is EKS, AWS managed Kubernetes service. So we don't have any control over the master service. So at the moment we've got just one server here, and that's defined in the VPC, no, EKS worker node. Yeah, if you go to the bottom, we've set the minimum size to 1, maximum size to 1, desired size to 1. We haven't specified the instance type for the node group, for the nodes in the node group. So by default it chooses t3.small, but you've got an option to change it, and you can say instance types equals, it's going to be a list, and you can say t3.small if you want, and so on. But by default it's going to give you t3.medium, I think. Let's check that. Okay, so we have our Kubernetes cluster ready. Kubectl version --short. So version 1.14.9 by default you get. Let's deploy a quick nginx deployment. Kubectl run nginx --image nginx. Cool, that's deployed. Kubectl get all. Okay, container is getting created, so that's the nginx pod. Kubectl get all. Cool, our nginx is running. Kubectl delete deploy nginx. That's deleted. Kubectl get all. And that's gone, and the pod is getting terminated. Okay, so our Kubernetes cluster has been created and we can interact with our Kubernetes cluster. And now let's log into our management console and see what resources it has deployed for us. So basically we will be looking at all these resources that has been deployed for us by Terraform. Okay, so I'm going to go to the browser and log into my AWS management console. So first I'm going to go to the VPC. Alright, so as you can see here, there are two VPCs. One is the default VPC when you create your AWS account, and that's the VPC that Terraform has created for us for EKS. And all the resources that Terraform deploys will have a name tag attached to it, so you can easily find out who deployed this one. So the name is Terraform EKS demo node with the IPC, CIDR 10.0.0.0/16. And if I look at subnets, so those are the two public subnets that Terraform deployed for us. These are public subnets. How do I know if it's a public subnet? If I click on that one, click on the route table, and you can see for the internet access, which is 0.0.0.0/0, it's going via the internet gateway, which means it has to be a public subnet. And similarly, the other subnet is also a public subnet. Okay, so we've got route table. And okay, I think I need to re-log in now. Okay, so AWS Management Console kicked me out, so I had to re-log in. And the route table, so we have these two route tables, and Internet Gateway, Terraform EKS demo. So that's the internet gateway that Terraform deployed for us. Okay, so that's cool, and let's log into the EC2 console, and we will see our security groups. So we've got 4 security groups. So these are the ones that's created by Terraform, and if I look at the inbound rule, so that's the public IP address of my workstation here, and I'm allowed HTTPS protocol, and we've got 443 allow workstation to communicate with the cluster API server, and that's the security group for the EKS cluster. And if I go to instances, so we've got one instance which is a t3.medium, and it has the security group attached. If I look at the inbound rules, so it's the cluster security group. Okay, so we've got all those things, and if I go to IAM, it should have created 2 rules for us. So basically I'm looking for this IAM role and this IAM role, and this one has got 2 policies, this one has got 3 policies. We've checked all these, and if I go to roles, IAM roles, and you can see here these 2 are the roles that Terraform created for us. And if I click on that role, cluster role, and you can see here it has attached the 2 policies that we talked about: Amazon EKS cluster policy, Amazon EKS service policy. If we go back here to the cluster, and if you look at the role, it's Amazon EKS cluster policy, Amazon EKS service policy. That's looking good. And if I check the EKS demo node policy, we have 3 policies: worker node policy, container registry read only, and CNI policy. So that's defined here: worker policy, CNI policy, and the container registry read only policy. So we verified that we have all the resources deployed by Terraform. So now let's tear this down. I'm going to destroy this entire infrastructure. Terraform destroy, that's it. Again, it's going to ask for the confirmation. It's going to tell you what it's going to delete. So we should be seeing that it's going to delete like 18 resources. So we know that it has deployed 18 resources. So now it's destroying all the 18 resources, and you can look at all the resources that it's going to delete, and just type in yes, that's it, and it's going to delete all the resources. So again, it's going to take the same amount of time. It might take from between 12 to 15 minutes for the destroy operation. So I'm going to pause the video and come back when it has been destroyed. Alright, the Terraform destroy command completed, and it actually took about 19 minutes. So you can see here the cluster deletion took about 10 minutes, and the node group deletion took about 8 minutes. So in total it took about like 19 to 20 minutes. And now we've got all our resources deleted, and if I do Terraform state list, you don't have anything. It's all empty now. And back in the cluster, I actually forgot to show you where to find the EKS cluster. So if you go to the ECS service dashboard, so that's where you will find your Kubernetes service under Amazon EKS clusters. So you won't be able to see any cluster here because I've ran the Terraform destroy command, but here's the place. Go to services and search for ECS, and in ECS it's under the clusters. So that's why you see the cluster, the state of the cluster, and the node group, type of nodes, and so on. Alright, so that's gone. And if I go to VPC, I'm now back to 1 VPC and 3 subnets, which are the default VPC and the default subnets. Back to 1 gateway. So our VPC, subnets, route tables, internet gateways are all gone now. And if I go to EC2 and look at the security groups, I'm back to 1 security group, the default security group, and I don't have any running instance. And we can have a look at the IAM policies and roles. And if I go to roles, and I don't see those 2 roles here, the Terraform EKS roles here. So everything has been destroyed, and this is how you use Terraform to create or provision your Kubernetes cluster in AWS using their managed EKS service. I hope you found this video useful. If you've got any questions, let me know. Please give this a try, and let me know if there is something that that's troubling you or that's not working right for you, I'll be happy to help in the YouTube comment section. And don't forget to subscribe to my channel. I will see you all in my next video. Bye bye.